In this lab video, I'm going to go over a practice problem of how to find an empirical formula. A couple of notes to remember before we work on this specific problem. To find an empirical formula, you have to memorize a few steps. Number one, write down the mass of each element. And in this example, because we're working with water, we'll be using elements iron, elements chlorine, and also H2O total. Number two, convert all grams to moles. Remember, to do that we use the molar mass from our periodic table. Number three, divide all moles by the smallest number. And the reason we do that is because all our chemical formulas are always whole numbers, like H2O, not H1O0.5. So in this problem, it says a 2.85 gram sample of FeXCl.ZH2O. That means that we need to solve for X, Y, and Z. Weighed only 1.71 grams after heating. So let's think about this, our data. So I have 2.85 grams FeXCl.ZH2O, and the goal of this problem is to solve for X, Y, and Z. Weighed only 1.71 grams after heating. So remember, when we heat it, we remove the water. So after heating means we have FeXCl. So if I subtract these, I get the grams of H2O, which gives me 1.14 grams of H2O. So this will be one of the first numbers I'm going to work with. After the reaction, a total of 0.5888 grams of solid iron was collected. I therefore have 0.5888 grams of Fe solid. So I know the mass of iron. I know the mass of water. We need to figure out the grams of chlorine before we can set up our empirical formula problem. Well, to do that, I can take the 2.85 grams FeXCl.ZH2O. I can subtract the 1.14 grams of water, and that would give me the mass of the iron and the chloride. So if I also subtract the 0.5888 grams of iron, then I'm left with just the mass of chlorine, which gives me 1.12, and I add an extra 8 in here by accident. Take that out. 1.12 grams of chlorine. So now I can start this empirical formula problem. So I have 1.14 grams of water, 0.588 grams of iron, 1.12 grams of chlorine. That's step one, write down all masses. Now I want to convert grams to moles. So I'm going to go from grams of water. I start with units of grams. So I need grams of water downstairs, moles of water upstairs. The same for iron. Grams of iron downstairs, moles of iron upstairs, and chlorine. Grams of chlorine downstairs to cancel moles of chlorine upstairs. We use the periodic table to get the molar mass. The number in front of mole is always 1. To get the molar mass of water, I know for H2O, I've got hydrogen and I've got oxygen. I've got 2 hydrogens. The mass of each is 1.01. For oxygen, I have 1 mass of 16.00 from the periodic table. And I add those together, 18.02 grams for every of water. So that is my molar mass as a conversion factor. So this number, 18.02. I needed to add those together because I have H2O as a chemical formula for iron. I just look at the molar mass of iron, which is from the periodic table, 55.85, and for chlorine from the periodic table, 35.45. And now I'm going to divide. So 1.14 divided by 18.02 gives me 0.06326. Moles of water. Grams cancel, so I take 0.588 divided by 55.85, and I end up with 0.010528. So I'm rounding at the end, and a few extra sig figs here. Moles of iron. And for chlorine, I take 1.12, my grams cancel, divided by 35.45, and I end up with 0.03159 moles of chlorine. So I could say a chemical formula of Fe.01 Cl.03 dot 0.06 H2O, but we always work with whole numbers in chemical formulas. So I divide all moles by the smallest number of moles to figure out what is that whole number mole ratio. And I can see my smallest number is the moles of iron, and divide everything by 0.010528. And I can see for iron, that's going to be 1 Fe. For water, take 0.06326 divided by 0.010528, and I end up with 6.009, which rounds to 6 moles of water. And then lastly for chlorine, 0.03159 divided by 0.010528, and I end up with 3.001, which rounds to 3 moles of chlorine. So I never round until the end, and I only round at this point if I'm very close to the whole number. And the question is to write down the formula of the hydrate, and now we write this as Fe, which is 1, Cl3 dot 6 H2O. Mole